Hi, welcome to my channel. I'm Maddie Astro, and this is Nebula Explained in 7 minutes or less, so let's get right in. So what are nebulae or nebula? They come from the term actually comes from the Latin, meaning mist or cloud, and the scientific definition is a cloud of dust and gas that is visible in the night sky, usually made of hydrogen and helium, and possibly some other trace gases too. So let's break this down further into the different types there are, and let's do that right now. So there are 4 primary types of nebula out there: emission, reflection, dark, and supernova remnants. So let's break these down further. In emission nebula, there are 2 primary types. H2 or star-forming regions are clouds of ionized gas that emit at optical wavelengths, have masses ranging from 100 to 10,000 solar masses, with densities ranging from a few to millions of atoms per cubic centimetre, and can be spread over several hundred light years with average temperatures of 10,000 Kelvin. These occur when hydrogen atoms are ionized by nearby O and B type stars, so they break down to hydrogen nuclei and electrons. These later recombine, but in an energetic state, emitting in optical wavelengths. Typically, one such wavelength would be 656.3 nanometers, which is the wavelength of hydrogen alpha, which gives these nebula their reddish hue. Another type of emission nebula would be planetary nebula. These are clouds of ionized gas that are formed at the end of the life of a sun-like star. They have masses ranging from 0.1 to 1 solar mass, with densities ranging from 100 to 10,000 particles per cubic centimetre, and can be up to 1 light year across, with average temperatures around 1200 Kelvin. Unlike H2 regions, the excited gas does not necessarily have to be H2, but contains significant quantities of He2 or O3, and this can give them their distinctive blue and green hues. Reflection nebulae are created when light from nearby stars is scattered or reflected from the neighbouring dust clouds. The scattered light is slightly polarised and has a spectrum similar to that of the illuminating star, but slightly bluer. This shift in colour arrives because the typical size of dust grains in the dust cloud are comparable to the wavelength of blue light. The result is that the light is scattered more efficiently than the larger red wavelengths. Dark nebula are interstellar clouds with very high concentrations of dust, have a mass range from less than 2,000 to over 1 million solar masses, with densities from 100 to 300 molecules per cubic centimetre, and can be greater than 200 parsecs across. The average temperature ranges from 10 to 100 Kelvin. The high concentrations of dust allow them to scatter and absorb optical light, making them practically opaque to optical light, and can be best seen in front of brighter objects such as emission nebulae. And finally, supernova remnants. These are a diffuse, expanding cloud of gas and dust that results from a supernova explosion. This can consist of material ejected from the supernova explosion, but also from the surrounding interstellar material that has been swept up in its expansion. Although not necessarily visible at optical wavelengths, they tend to be very powerful in the radio and X-ray ranges. They can be several 100,000 years old, expand tens of parsecs before they eventually dissipate. Well, that's this for this video. I hope you've enjoyed it. I've enjoyed making it, It was a short video. I hope you liked them. If you have any suggestions for further videos like this, please put them down in the comments. I'm really wanting to get some kind of feedback from you guys on this, because I really want to be able to do more of these, but I also want to do them on topics that you want to talk about, what are interest to you, not just me. So please do that. The only requirement is that it has to be to do with either astrophotography, astronomy, or some science or technology related topic. So yeah, that's it for this video. As I say, I hope you've enjoyed it. I've enjoyed making it, and I will see you on my next one. Until then, clear skies. Bye.